60-degree rotation of triangle ABC about point P. First, draw a segment from P to A. Then use a protractor to draw a ray to form a 60-degree angle with segment PA. Next, draw A' along this ray so that PA' is equal to PA. Then repeat this process for point B. Draw a segment from P to B. Then use a protractor to draw a ray to form a 60-degree angle with segment PB. Next, draw B' along this ray so that PB' is equal to PB. Then repeat this process again for point C. Draw a segment from P to C. Then use a protractor to draw a ray to form a 60-degree angle with segment PC. Next, draw C' along this ray so that PC' equals PC. Then draw a triangle A'B'C', which is a 60-degree rotation of triangle ABC about point P. Draw a point P. Graph triangle ABC with vertices A31, B34, and C11, and its image after a 180-degree rotation about the origin. First, graph triangle ABC with vertices A31, B34, and C11. To find the image of triangle ABC after a 180-degree rotation about the origin, find the image of each vertex A, B, and C after a 180-degree rotation about the origin. Use coordinate rules for rotations about the origin. For a rotation of 180 degrees about the origin, the image of point AB is point -A, -B. The negative of 3 is -3, and the negative of 1 is -1. So point A31 maps to point A', -3, -1. Similarly, point B34 maps to point B', -3, -4, and point C11 maps to point C', -1, -1. To complete the graph of the image, draw line segments connecting the vertices. So triangle A'B'C' is the image of triangle ABC after a 180-degree rotation about the origin. Segment RS with endpoints R1, -3 and S2, -6, and its image after the composition. A rotation 180 degrees about the origin followed by a reflection in the y-axis. First, graph segment RS with endpoints R1, -3 and S2, -6. Rotate segment RS 180 degrees about the origin. The image of point AB after a rotation 180 degrees about the origin is point -A, B. The negative of 1 is -1, and the negative of -3 is 3. So point R1, -3 maps to point R', -1, 3. Similarly, point S2, -6 maps to point S', -2, 6. Complete the graph of segment R', S' by drawing a line segment connecting the endpoints. Next, reflect segment R', S' in the y-axis. The image of point AB after a reflection in the y-axis is point -AB. The negative of -1 is 1, so point R', -1, 3 maps to point R', 1, 3. Similarly, point S', -2, 6 maps to point S', 2, 6. Complete the graph of segment R', S' by drawing a line segment connecting the endpoints. So segment R', S' is the image of segment RS after the given composition. Graph Does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. Part A. The center of the triangle is the intersection of its altitudes. Notice that a rotation of 120 degrees about the center maps the triangle onto itself. So the triangle has 120-degree rotational symmetry. Part B. Notice that no rotation of 180 degrees or less maps the triangle onto itself. So the triangle does not have rotational symmetry. Part C. The center of the hexagon is the intersection of its diagonals. Notice that a rotation of 180 degrees about the center of the hexagon maps the hexagon onto itself. So the hexagon has 180-degree rotational symmetry. Does the